So we used to think that atoms are the smallest particles in this universe and that atoms cannot be divisible. But then, one time on the year 1897, someone found out that it is not true. Through his experiment in his cathode ray, J.J. Thomson found a new ray that is affected by a magnetic field. From the findings of the experiment, he had three conclusions. First, that cathode rays have negative charges. Then he also knows that the ray is made of particles that are 1,000 times smaller than hydrogen atoms, and that different cathode metals give up the same ray properties regardless of their initial properties. The conclusion is that atoms may contain small negative charged particles. What are the particles? Then they name it as the electrons.
Soon after, the new Thomson atomic model was found. Yet on the next years, more experiments got weirder results, and these results can be explained by classical physics.
So this next experiment has something to do with light. And as we all know, light has different wavelengths. The shorter the wavelength, the higher the energy level. We expect that as wavelength becomes super short, the radiance or the brightness intensity of reflected light from an object would become super bright. But in the reality, according to the blackbody radiation graph, X-rays they have super short wavelengths, but when shot to an object in high intensity, the radiance suddenly dropped down, according to the graph. What could explain this? A German once then explained, well, if short wavelengths can't make objects infinitely bright, that means there should be like some kind of speed limit, energy limit for that object perhaps. And this German said that the speed limit should be a fixed number then. It cannot be an arbitrary number. Then this German said the value should be always that concrete number. So then it should be quantized maybe. It should be quantum. Maybe all speed limits should have a fixed number then. And that's where this German named Max Planck came up with the term quantum. And he hypothesized that energy comes in discrete packets and measured by his famous Planck constant, a super small number.
Albert Einstein then developed a theory which is called the photon theory of light and the photoelectric effect. This theory explains that when light hits an object, the object will emit electrons. These electrons are then called photoelectrons. In the formula shown, a frequency must reach a minimal threshold for the effect, which means that the energy of the wavelength must be high enough in order to achieve this.
But then, when the energy must pass a barrier, that barrier should have a discrete number. It should have a concrete number. Then this also proves that even wavelengths has discrete packets of energy, which further approves Planck's theory of quantum light and the quantum world.
Aside from the previous experiment, Einstein has also found that photons have mass too. This is through his equation. Soon after, two scientists called Niels Bohr and Ernest Rutherford in 1913 proposed a model called the Bohr model. This system consists of a small dense nucleus surrounded by revolving electrons. There are multiple electron shells. The higher the shell, the higher the electron energy level.
So now we know that electrons exist and energy comes in discrete packages. But one day, Compton, a physicist from the USA, did another experiment. He shot electrons with light. He found out that the angle of collision of the light and the electron can affect the change of energy levels of the light. So we can say that light can change colors by crashing into electrons. The shorter the angle, the longer the angle, the more energy level is changed.
The Compton effect, which was previously explained, can only be explained only if light had a wave-particle duality. This connects to another theory which is called wave-particle duality. The theory explains that light can behave as a wave and a particle. Another theory, called the Broglie hypothesis, proposes that all matter exhibits wave-like properties, which is basically saying that all objects can behave as waves.
So from these experiments that are done, it became a part of a new movement in the physics world, the quantum physics or modern physics that we learn today. And without modern physics, there will be no toaster, no laser beams, no GPS. We would not have computers or mobile phones. So we could see a clear positive impact of the amount of new products that are produced based on this new theory.